In this video, I will be talking to you about some database terminology. In particular, I will be discussing the features of a relational database. Databases make use of tables to store data. In the database world, tables are often referred to as entities because each table should be about a single idea or entity. Each table contains related data which are separated into columns and rows. Each table starts with the table name or entity. The entity then contains attributes or calling headings which represent field names. Columns go from left to right and are the first row in a table. Attribute examples, as you see in this rep table, are rep number, last name, first name, street, city, state, zip, commission, and rate. Rows or records go from top to bottom. Each record in a table contains individual information about the entity. For example, for this rep table, a rep number, which is rep 20, is represented by Valerie Kaiser at the address 624 Randall, Grove, Florida, 33321. She gets a commission of $20,542.50 at a rate of 0.05. Essentially, fields maintain information about the records in that table. Each table in a database must have a way to ensure each row of the data is unique and that there are no duplicate rows of information. This is done through the use of a primary key, which is also denoted as PK. A primary key is a field that has no repeating information for any of the records in a table. Let's examine this orders table and figure out which fields would make the best primary key. Keep in mind that long text and repeating information from one row to the next does not make a good choice. Let's start with the rep number column. Is there repeating data among the different rows? Yes, 35 appears in two rows, therefore is not a good choice. Let's look at the credit limit column. 7,500 is listed twice, therefore it's not a good choice either. For the balance column, there is no repeating data, but two customers could potentially have the same balance, so it's not a good choice either. There are similar reasonings why street, city, state, and zip would not make good primary keys. Let's look at the customer name. Each name is unique and will never repeat because two customers will never have the same name. But this is not an ideal primary key because there would be a lot of text to repeat and potentially make spelling errors with. In this table, the best choice for primary key would be the customer number. And this is because it consists of short numbers that would be less likely for you to make a typing error with. And each row is also unique because each customer has a different customer number. Sometimes it's not possible to achieve row uniqueness by a single column or attribute. When more than one column is used to make up a primary key in a table, this is known as a composite primary key. When a composite primary key is needed, all attribute names that make up the composite primary key are indicated with PK. Let's examine the order line table to see which column or columns make sense for the primary key. Let's start with price. Price does not make sense because two orders can have the same price. Num ordered, part number, and order num all have repeating data, so they don't make sense by themselves. Let's see if we can figure out what this table is being used for so we can make a better determination of which columns make sense for the composite primary key. The table looks like each row represents the order number and which part and quantity and price of the part is being ordered. It would then make sense to use the order number and part number as the primary key for this column because the number ordered column would not allow for unique rows when paired with either the order number or part number column. Also, the part number is directly related to the order number and not to the part number and not the order number itself. A collection of multiple tables are what make up a database. Relational databases are formed when tables are connected together through relationships. The relationships are formed when you connect the tables through their logical relations by the use of the primary key to create business rules. There are three types of relationships: one-to-one, one-to-many, and many-to-many. The majority of relationships are one-to-many. All many-to-many relationships should be resolved to a one-to-many relationship by adding a connecting table. One-to-one relationships should only be used when there are no other options and as a lookup table. As indicated in the diagrams, one side of the relationship is a solid line, and the many side of a relationship is a crow's foot. With a one-to-many relationship, you are saying one table is related to many items in another table. We will now form relationships for a premier database. We will use only one-to-one relationships since they are the focus of this class. To form a relationship, the primary key of one table is added to another table and is designated as the foreign key in the related table. Let's take a look at the premier database that is discussed in Chapter 1 of your textbook. I recommend you print out a copy of the premier database from Talon inside the Course Databases module if you have not already done so. I have included the table names and their fields or attributes in the boxes above to get us started. If we take a look at the relationship between the sales rep and the customer table in the premier database, you are saying that one sales rep is associated with many customers, but each customer is associated with only one sales rep. This text definition of the relationship is known as a business rule. Now let's add relationships to the other tables. What other tables should be related? Let's think about how things are done in this business. A rep takes care of a customer who places an order for parts that have various different warehouse locations. This means that we have a relationship that should occur between the rep and customer tables, the customer and orders table, the orders and order line table, and the part and order line table. Now that we know which other relationships to add, let's start with the relationship between customer and orders. To get started, ask the question: can one individual customer place many orders, or can one individual order have many customers? It does not make sense for one order to have many customers. Therefore, we know the one side of the relationship line should be with the customer table. Now, to form the relationship, we have to add the customer number foreign key to the orders table and put the relationship line with the many side pointing to the foreign key in the orders table. The other relationship lines are built the same way. One order can be associated with many order lines, and one part can be associated with many order lines. We have discussed a lot of relational database terminology in this video. Don't forget to write journal topics from the Talon in your journal. They may not all be listed on the summary sheet, so be sure to watch the video again to get the definitions you need. Not all content of these videos is in your textbook. Thanks for watching.